Okay, so here's the initial setup. Again, there's the function for height as a function of time, and the eagle snatches the arrow at 385 feet above the ground on the way down. Okay, so number one, the point for 707.9 is on this graph. What does that point mean? Come back. Okay, so the point for 707.9 is on the graph. What does it mean? Diana? Right, she said at 4 seconds, the arrow was 707.9 feet above the graph. Okay, why is that question important? Because what are you looking at? Are you looking at a wire that's bent? No, you're looking at points. When you look at this continuous curve, you are thinking, oh, that's just a whole mess of points. And every point has a very specific meaning in this situation. So this particular point for 707.9 right there. That is the point, like she said, after 4 seconds, the height of the arrow is 707.9 feet. So as time goes by, all these points emerge and form the graph. Okay? You have to think of graphs that way. As time increases, we get every single point representing the time and the corresponding height. Okay, what's the highest point attained by the arrow? Did we get it? Let's see. Matt thinks he got it.
900 feet.
Exactly 900?
That's what I got. One off.
A little bit, just under 900?
Yeah.
Just under 900. I'm showing 899.9. So is that what you guys are getting? 899.9, or just below 900 feet is the highest point. Okay, so make sure you know how to operate your calculator and get a maximum point. Okay, if you need help with that, office hours, or send me an email or something, or talk to a friend. But you got to know how to get maximums and different things. Okay, how long after reaching the highest point does the eagle snatch the arrow? How long after reaching the highest point does the eagle snatch the arrow? Let's see here. Braden.
Approximately 6 seconds.
6 seconds? How'd you get that?
Well, I calculated the time at 385 feet, and I calculated the percentage at 899.9 feet.
Okay, let's do that first thing first here. So, I don't know how close I can get. Let's see, man. All right, there's 3. I got 386. I'll just zoom in one more time. So how can you do this on your calculator? So how did you get that time for reaching 385 feet, Braden?
You can do in your plot
Yeah.
section, you can type in a y value, so if this is 385,
Okay.
and then you can calculate the intercept.
All right, so that's one way to do it. So what about using the graph? How can we use the graph to find the time that it reaches 385 feet? Somebody new? Anyone able to use the graph? So yeah, you can use the plot the table. But what about using the graph to find the time for 385 feet? Natalie, were you able to do that? How can we? Yeah, Christopher.
Just the changes in X.
Changes in X? Well, the point is, so we need a height of 385 feet. How can we get that value of x that corresponds to 385 feet?
I just used I went over just like you did right there.
Trace.
Yeah, just went over.
Yeah, so you can trace on the graph. Zoom in. If you zoom in far enough, you can trace on the graph. Is that a hand?
Yeah.
Okay, go ahead.
You said create another graph at y equals 385.
Yep.
Find the intersection.
Yeah, this is a really good way to do it because we'll get it exactly. So set y equal to 385, a second graph, and it'll give you a horizontal line at 385, and we know that it'll be the intersection of those two. So y equals 385 is kind of what I'm showing here with a dotted line, and then the intersection. So Braden, it says 13.11 seconds. Is that what you got for that? So that's how long after reaching the highest point does the eagle snatch the arrow? Is it 13.11 seconds? Yes?
Yeah, 13.13. And then the height where the highest point calculates out to 7.4.
Okay.
If you just use the same.
So he's saying that the value of x at 385 for y is not the answer to this question. Do you see that? What is the value of x? That's the total time since the arrow was shot. But this question is asking the time since the highest point to when the eagle catches the arrow. So we've got the 13.11. And then what was...
Calculates at about 7.4.
So the highest point occurs at x equals 7.45. And the eagle catches the arrow at 13.11. Is that right? Is that what I remember correctly? So, how much time does it take to fall from the highest point to when the eagle catches the arrow? You're going to subtract, right? Final time minus initial time. And it equals? That's it. Is that what you got? Yeah. So this is actually asking for a change in x. It's not asking for an x value. It's asking for a change in x starting at this 7.45 seconds, ending at 13.11. Okay, so I added this question 4 in there. So this is number 5. Number 6. Okay, number 4 is a really important question. It goes all the way back to the beginning of this. Write an expression for the average rate of change of height starting at x equals 0.5 seconds for the time period lasting 3.1 seconds. Okay, so this is super important, and we did this back in Module 3, both writing expressions using function notation, and then average rate of change. So this number 4 is maybe arguably the most important question. So how did we do? So an expression for the average rate of change of height starting at 0.5 seconds. Who's going to get to do this? Let's see. How about James? How did it go? Sean back there, how'd it go? Okay. I can't remember her name. Who sits next to, Hia. How did this go? Number 4, write an expression for average rate of change of height. Okay, let me just interrupt you. What's F? You got the right idea. It's just we didn't call it F, right? What's our function? H. Okay, so we give it a shot. That's okay. Okay. So in general, what is she, so just before we get into the details of that, in general, what is she setting up? What basic principle here? What is she setting up in making that expression? What's that? Change in output over change in input, right? Change in output, in this case, the change in height over change in time. That gives us average rate of change, okay? That gives us average rate of change, that's right. So now let's get into the details. So what about her change in height? Or let's do change in time first. What about the change in time? 3.1 minus 0.5.
It'd be 3.6.
Okay, he wants 3.6 minus 0.5.
Question's a bit unclear about whether.
No, it's not. It's not. It says, for the time starting at 0.5 seconds, for the time period lasting 3.1 seconds. There's nothing ambiguous about that. For the time period lasting 3.1 seconds, starting at 0.5 seconds. What is the change in time? For a time period lasting 3.1 seconds, that's the change in time, 3.1 seconds. Okay? This, I'm giving you, sometimes it gives you the starting time and the finish time. But sometimes it doesn't. Sometimes, here I'm giving you the starting time and the change in time. That is delta x. Okay? For the time period lasting, that's delta x. So therefore, what is the change in time? You can just write 3.1. If you want to write 3.6 minus 0.5, that's fine. But we can just write down 3.1. It's a change in time. Okay, now what about the change in height? Do we have to alter that? So we do need final value of height minus initial value of height. Do we have that? Yeah, so now we're going to need 3. The final value of height will be the height at 3.6 seconds since being shot. Minus the height at 0.5 seconds since being shot. Okay, so just this idea right here of, so when you were working on this, if you never came up with anything like that, then you need to understand and recognize and be able to do this soon. You got it. Something's got to change. You have to see that we can express output values with function notation. We worked hard on this in Module 3. Don't let it fall out of your brain. It's really important. We can express without finding the value, without knowing the formula. We can express output values with function notation. H of 3.6 represents the height of the arrow at 3.6 seconds. H of 0.5 represents the height of the arrow, a number, a value at 0.5 seconds since it was shot. So if you worked on number 4 and you never came up with anything remotely like what I've just put in red, then get with the program. Remember, don't let it, learn it, okay? All right, number 5. If the eagle had not been around, when would the arrow have hit the ground? Newer, did you get it? No? How would we do it? Just like looking at this graph, how would we know when the arrow hit the ground? What would it be? What would it have to do with? I'm sorry? But I'm asking for a time. How long did it take for the arrow to come back and hit the ground? I'm asking for a time. So yeah, maybe it fell right where he shot it from. But I'm saying how long did that, how much time went by from when he shot it to when it came and hit the ground again? What's that? Yeah, how do we get that number? Not sure. How about Jonathan right here? Did you get that? Or how do you go about finding the amount of time it takes? Okay. He said make another graph letting y equal to 0 and find which intersection. Where should I go? Down here. There's also, this is called a, on your when a function hits the x-axis, you know what that's called? A 0 or a root. A 0 or a root. So a root or a 0 is a value of x that makes the y equal to 0. And that's what we want. We want the height to be back to 0. I got 14.93 seconds. Is that what you got? So this would be neglecting air resistance, okay? Neglecting air resistance in a kind of more theoretical situation here. 14.93 seconds. Okay. And then just reviewing what we did last time. For equal increments of time, how does the height change? How does height change? Kenneth, for equal increments of time, we let equal changes in time go by. How does the height change?
It increases and decreases.
What's that?
It increases and decreases.
In the first part, for equal increments of time, up to, what did we say? How many seconds was it? 7 point, so up to 7.45 seconds, equal increments of time means the height goes up. After 7.45 seconds, equal increments of time means the height goes down. Good. You're on a roll. Okay, so how do changes in the height change? How do changes in the height change for equal increments of time?
They're changing at a decreasing rate.
Now I'm asking about the changes. I'm not asking about anything about rate. I'm asking just about the changes. What do the changes do? For equal increments of time. So they either increase, decrease, or stay the same. That's all they can do. They decrease. Always? Oh, jeez. What about before 7.45 seconds? What do the changes in height do? Danny, I'll let you go.
They begin to increase.
They begin to increase. When x is less than 7.45 seconds, he says the changes in height decrease.
Yeah.
Eric likes it. Danny still wants it. Cody, what do you think? You agree?
Yeah.
Eitan, what do you think? They're saying that the changes in height, for x less than 7.45 seconds, the changes in height decrease. Or they're saying increase, sorry.
They increase at a decreased rate.
They increase at a decreased rate. The changes increase at a decreased rate. Eric.
Okay, so just to make things clear,
That's what I try. I try so hard for that, Eric.
at the very top of this graph, it's at 0. It's not moving. It's at 0 velocity. So it was shot at 240 feet per second. So as it gets closer to the top of the peak, it will slow down. And when it gets to the top of the peak and it
Okay.
wants to fall back to Earth, it's going to speed up until it hits the ground.
Yeah, but we're talking about changes in the output. So yeah, I don't want to talk about speed. I want to talk about the output quantity of height.
So the changes in the output will decrease as you get closer to 7.4 seconds. And after 7.4 seconds, the changes of height will increase.
Okay. So now he's disagreeing with them. They said the changes in height increase, and now he's saying the changes in height decrease. We're just talking about up to 7.45 seconds. Up to 7.45 seconds. Sarah, what do you think?
They decrease.
When? Where?
Well, as it goes from 0 to 7.
Okay.
So,
She says decrease. Are these changes positive or negative? And what question do we ask now? Are they getting
less
more positive or less positive? They're getting less positive. These changes are getting less positive. Numbers that get less positive, are they increasing or decreasing? Okay, the changes are, I'm going to kind of, the changes are decreasing. This one is less than this one. This one is less than this one. This change is less than this. This change is less than this. Those changes are decreasing. Is it okay? These are positive changes in height. The height's going up. Those changes are decreasing. Each change is less than the one before. Okay, on the way down. Let's see if we learned anything last week. We're looking at the changes in height, these little vertical black bars that I'm drawing. For each equal increment of time, a horizontal change, right? A horizontal change in time on the graph, we get a corresponding change in height. Are those changes increasing or decreasing? Decreasing, but they're getting longer.
They're becoming more negative.
They're becoming more negative. Right, so I heard most of you say decreasing. Good. Okay, so these changes are negative, but they're getting more negative. Values that get more and more negative are still decreasing values. So even though those changes are getting bigger in amount, because they're negative changes, bigger and bigger negative changes are decreasing. So the changes in height are, starting at time equals 0, increasing or decreasing? Decreasing the whole time. The changes in height are decreasing the whole time. They're getting less positive and then more negative, the changes. So therefore, what about the rate of change? The rate of change is decreasing the whole time. Again, the rate of change gets less positive, and then the rate of change gets more and more negative. Okay? And so now that has to do with the fact that the speed is always either slowing down going up or speeding up going down. And that's a negative rate of change if up is positive. So if up is positive and we're slowing down going up or speeding up going down, that's a negative rate of change. Or sorry, decreasing rate of change. Decreasing rate of change. Okay, any questions on all these questions?